For years, astronomers have searched for planets by looking for the light they reflect, the shadows they cast, or the tiny movements they force on their stars. But there is another kind of planet, one that may have no star at all. Imagine an Earth-sized world drifting through the Milky Way in almost complete darkness, invisible, cold, and traveling alone between the stars. It sounds like science fiction, but astronomers have found evidence that worlds like this really exist. And the strangest part is how they found them. They didn't photograph the planet. They didn't see it crossing a star. They saw a star suddenly become brighter. For a brief moment, something invisible had passed in front of it. The clue comes from one of the strangest effects predicted by Einstein's theory of relativity. Gravity doesn't simply pull objects together. Mass also bends space-time, and when light passes through that distortion, its path can curve. Astronomers call this gravitational microlensing. Think of a tiny object passing directly in front of a distant flashlight. You might never see the object itself, but if it acts like a microscopic magnifying glass, the distant light suddenly changes. That is exactly what astronomers watch for. When a planet drifting alone through the galaxy passes almost perfectly between Earth and a distant star, its gravity can temporarily magnify that star's light. The star appears to brighten, and then, just as quickly, it returns to normal. The entire event can last only hours or days. After that, the signal is gone. There is no second chance. This makes rogue planets extraordinarily difficult to detect. But it also creates something remarkable. A planet doesn't need to shine. It doesn't need to orbit a visible star. Its gravity is enough. In a major survey using observations from the Mount John University Observatory in New Zealand, astronomers searched thousands of stars toward the crowded center of our galaxy. They found brief microlensing events consistent with planet mass objects. Some appeared to be traveling without a detectable parent star. The observations were also compared with data from another survey, OGLE, providing independent support for the phenomenon. And then came the bigger question: how many of these hidden worlds could be out there? NASA-supported research has suggested that free-floating planets may be far more common than the planets we normally discover. One 2023 analysis estimated that the Milky Way could contain trillions of rogue planets, with Earth-mass worlds potentially far more numerous than previously expected. But that is an estimate based on survey data and models, not a direct census of trillions of confirmed planets. If that estimate is even roughly correct, the familiar picture of our galaxy begins to change. The stars may not be surrounded only by planets. There may also be countless worlds moving silently between them. And that raises an even stranger possibility. What happens to a planet after it loses its star?
When a planet is torn away from its star, its fate depends on what happens next. Some rogue planets may have been ejected early in their planetary system's history. Young planetary systems can be chaotic places. Massive planets interact gravitationally, changing one another's orbits. A close encounter can accelerate a smaller world so violently that it escapes the gravitational pull of its star completely. The planet doesn't stop existing, it simply loses its home. And once it escapes, the darkness becomes almost permanent. Without a nearby star, its surface would receive almost no ordinary starlight. Temperatures could fall dramatically. Any oceans exposed directly to space could freeze. But that doesn't necessarily mean the entire planet would become completely dead. This is where established science begins to meet uncertainty. A planet can have internal heat. Radioactive elements inside its rocks release energy over enormous periods of time. A massive planet can also retain heat left over from its formation. and beneath a thick layer of ice, internal heating could potentially keep liquid water from freezing completely. Scientists have proposed that some free-floating worlds could therefore maintain subsurface environments capable of supporting chemistry associated with life. But this is an important distinction. No life has been detected on a rogue planet. There is currently no confirmed evidence that any free-floating planet is inhabited. The mystery is about what conditions might exist there. And the deeper astronomers look, the stranger the possibilities become. Because gravitational microlensing can reveal the presence of a planet without the planet requiring to orbit a star. It gives scientists a way to search for an entire population of worlds that conventional exoplanet techniques can miss. Transit surveys, for example, are extremely effective at finding planets that regularly cross in front of their stars. But a rogue planet has no star to cross. There is no predictable orbit, no repeated transit, no obvious destination, only a fleeting distortion of distant starlight. Future observatories could dramatically expand this search. NASA's Nancy Grace Roman Space Telescope is expected to survey huge numbers of stars toward the center of the Milky Way, using gravitational microlensing to search for planets that would otherwise remain hidden. Researchers estimate that Roman could detect hundreds of Earth-mass rogue planets if the underlying population is large enough. That could transform the mystery. Instead of asking whether rogue planets exist, astronomers may eventually be able to measure how common they really are. And that number could tell us something profound about how planetary systems form. If enormous numbers of planets are wandering through interstellar space, then planetary systems may be much more violent and unstable than our own quiet-looking solar system suggests. Worlds may be born around stars, then thrown into darkness. Others may form in unusual environments and never belong to a star at all. And somewhere in the Milky Way, an unseen planet could be passing between the stars right now. It might have mountains, it might have frozen oceans, it might have an atmosphere buried beneath layers of ice, or it might be nothing more than a cold, lifeless rock. From Earth, we may never know, because the universe has given us an extraordinary limitation. We can sometimes detect a world without ever seeing the world itself. A tiny gravitational fingerprint can reveal that something is there, and once the signal disappears, the planet disappears with it. Perhaps the most unsettling question isn't how many rogue planets exist. It's how many have already passed through our galaxy unnoticed, and how many are still moving through the darkness, waiting for gravity to reveal them.